In this video, I'm going to go over some raycasting basics, and raycasting is really important to have in your game because it allows you to programmatically see things. I have this rig scanning the area plus or minus 30 degrees on the X, Y, and Z and reporting back what he finds. If I get in the way, oh, look at that. It found my head, it found my upper arm, and the wall is blocking it, but you can also have an ignore list, right? So we can ignore, say, things that are transparent. I'm ignoring his little shield here, right? Because I'm saying, hey, that's part of the ray assembly. Don't have the assembly block the ray. I thought that'd be pretty cool. Let's go ahead and get started with some ray casting. I have an empty base plate right here, and let's go ahead and get an NPC for our ray casting. That's pretty convenient. So I'm going to go to the avatar tab right here. I'll go to rig builder, and you can pick whatever you want. I'll do an R6 because I never picked them. How about a mesh avatar? Cool. And let's go ahead and move it so that it's not too far from us when we join the game so we can see it right away. All right, on the rig, first thing I want to do is set up a beam that's going to follow my ray, right? So the ray casting itself is invisible, but we want to be able to see it for educational purposes. So let's open the rig. We're going to go to the head because that's where we're going to cast our beam out of, or our beam and our ray. We'll hit the plus, hit an A for attachment. We need 2 attachments for our beam. So ATT0, remember, this is just for visual effects. It's not actually the ray casting. I'm going to do a Control D to make another attachment, or you can add one manually. Yeah, let's go ahead and make that ATT1. We can move ATT1 out a bit so when we connect the beam, we can see it. Let's go to ATT0, hit the plus, add a beam. There we go. Now get the beam. We're going to go to attachment 0, click that spot right there, hit ATT0, attachment 1, ATT1, we got a beam. All right, so select this camera face. That'll make it so that you can see it a little better. The width, let's make it thin like a ray. Now the ray is like needle thin, but we can pretend this is going to be the ray. It's going to follow the ray exactly. All right, so we went 0.1, 0.1. I think I'm going to make it so it's a little easier to see. So the transparency, I'm going to make that 0. So it's fully opaque. And then maybe the light emission, maybe make that 1 so that a little bit shiny. Yeah, more beam-like. All right, that's pretty good. Let's put the beam back into his head. How do we do that? Go to ATT1, that's the one we stretched out, and position is relative to his head, to the parent part. So I'll just make that position 0, 0, 0. ATT1 goes back into his head. We can't see the beam. All right, now let's go to the rig itself, and let's add a script. Let's hit the plus sign on the rig, hit an S, there's a script, find your script, name it something that makes sense like cast ray. And we can make this a little bigger. There you go. That you can probably see that, right? All right, I need my head of my rig. So I'll say local head equals script.parent.head. There it is. And let's get the direction the head is facing. So I'll say dir. My rig's not moving around, so I don't have to update my direction. We'll do head. And then I need the C frame. You could do .C frame, but the new cool way of getting the C frame is to say get pivot, right? But it gives you the same stuff, right? Dot look vector. All right, let's work on our visual representation of our raycast before we work on the raycast. So we need this function to follow out our ray. I'm going to call that function create visual helper. So you know it's a visual helper. It's not part of the raycasting stuff. I want to pass in a start position. I want to pass in a direction, and that's going to be of length 1. It's just going to be a direction we're pointing in, and then the range of the beam, right? So this will be a vector. This will be a scalar, like a single number, like 30. If we multiply them together, we're going to go 30 studs out in a certain direction. And we'll get the head, find that ATT1. We can do world position. We'll get our start position plus the direction times the range, right? So we're going to start here and then we're going to go out in this direction, that many studs. Let's go ahead and wait 0.3 seconds and then we'll retract it just so we could do it in a loop and you can see it shooting out, right? So we'll do ATT1 and I'll just use the position because we'll reset it to 0. Right, that was a little trick that I showed you right when I was doing it by hand. Cool. We'll do a little while loop, really short, while true do. And then I'll do my create visual helper. I'll get the head's position. That's going to be the start position, the direction, and how far I want the beam to go out. And then let's just wait 0.2 seconds. Now, if your NPC is running around, the reason I'm passing direction in is because if the NPC is running around, you may want to update the direction of the head, right? So that you know where it's at. And then the head position is going to update. That won't be a problem. But this one, you're going to have to get that reset every time you go through the loop. Let's go ahead and try this out. You can keep that direction up here if you want because our NPC is not moving. But I wanted to show people that in case they're using this for AI. And let's check out how our beam is doing. That's pretty cool. All right, but it doesn't stop, right? It's not really a ray, it's just the beam. It's the visual representation. We got a little more coding to do. Let's go ahead and turn our game off. We're going to go back to our cast ray script that's in the rig. And let's add another function. I'll add it underneath my visual helper. It doesn't really matter though. You can add it above or below. Let's do a local function. And I'm going to call this cast ray. So this is the actual ray casting. We are going to pass in the start POS, the direction, and the range, just like the beam. I did that intentionally. All right, now we'll do a local result equals workspace : raycast. And you get a little bit of a IntelliSense up here helping you out. Oh, the origin would be the start position, right? That's virtually the same thing. And then we'll do comma. We need the direction. Ooh, but this direction is a little different. If you look, this direction is considering that there is a length associated, and mine is just of length 1. So I have to do my dir times range right here. Now you have another argument, raycast parameters. We're going to get to that in a little bit. That's going to be your exclusion list and things like that. All right, so we may or may not hit something with our ray. So we have to check. If there is a result, then we're going to do something. We hit something, right? Let's find out what it is. Let's call it a target. And I'll say result dot, ooh, we got lots of cool stuff here, right? And we have the instance that we hit. That is a base part or a terrain cell. Well, let's see what that is. Let's go instance, and then we'll print it out. Print, how about target equals target.name. Now there's other things that we get back too. Let's return some information. So I'm going to get my result again. And we got the position where it hit something in the world. Let's return that. And then we have result distance. Ooh, that's valuable. There we go. There's our distance. We come down here to call our raycast. Let's do that right underneath where we get the direction. I'll say cast ray. And start position is the head dot position, right? And we have a direction and we have a range. Whoops. Just like that. All right. Now we're going to get back a position. Oh, let's do this. let's say local POS for position, and then dist for the distance, right? So when we call this, we return these two values. They're going to get stuffed right here in the POS and the dist. What does that do for us? Well, the distance can replace this 30. But what happens if we don't hit anything? We're not returning anything. That's kind of sloppy. But what I'm going to do here is I'm going to say distance, and if the distance is nil, I'll say or 30. So I'll provide a default value. That's a little trick. It's pretty convenient. I do that in JavaScript all the time. So if you get a nil, you can put a default value in there. Now when we check out our raycast, we can't see the raycast, but the beam is going to mimic the raycast. Now in order to test this out, let's go over to our workspace and put a part in front and see if he can detect the part. Home, part, and we just go ahead and make it bigger. Go ahead and anchor it. Where's my anchored? There we go. And we could call it something fancy if you want, like blocking part. I don't know, wall. How about wall? There we go. All right, so now when we play this, it's going to hit the wall. Make sure that it doesn't go more than 30 though, or you won't quite get it. So I'll hit the play, and our beam's going to start up. Let's go to view, output. Oh, look at that. It's hitting the wall and it's counting it off. All right, what if I get in front of that beam? Oh, yeah, you see that? It stopped it. Now I have a delay in there, right? The raycast itself is instantaneous, but I have a wait. So now it's hitting the handle. That's the handle for either my hair or my hat, probably my hat. We're going to get rid of the accessory stuff. You can see how when he turns, the beam sometimes doesn't quite get to the head. That's because the mesh part, right? You're actually hitting the part itself, but the mesh part makes it look a little bit different. So you're not quite getting there all the time, but it is actually hitting the part. All right, nice. Let's go ahead and modify our script some more. I'm going to turn this off. We want to put some raycast parameters in there so that we can get around stuff that we don't want to detect. Let's scroll to the top of our cast ray script, and I'm going to add my parameters up here. So I'll call them params, and they are of type raycast param. So raycast params.new, and we're going to have to give it a few values. We'll say params. We need the filter descendants instances. This is handy because if you list something, all the descendants are going to be included in that filter list. So we'll say equals, whoops, it's going to be curly brackets. It's going to take a table type, say script.parent. We're going to add the character to our filter descendants instances so that nothing in the character is going to affect our raycast. All right, and then I have to put one more thing on these params. I need the filter type because there's an include and exclude. I always use exclude. So that's of type. We'll do the enum, and now we got to get our raycast filter type. And we got include, exclude. There used to be whitelist, blacklist, but they're deprecated. So exclude will do it. All right, and then you could add other stuff too, right? So yeah, the params, maybe we want to do ignore water. True. And if you know how to use collision groups, right? Collision groups is also an option you can use. So we have the collision group stuff. And I'm going to do another video on collision groups. That's getting a little bit more sophisticated, but maybe you have different teams and different collision groups, and you can exclude them in one fell swoop or include the ones that you want in one fell swoop. All right, so we got this parameters object. How are we going to put it in our array? Oh, let's just look to see where the raycast is happening. And then, comma, Control V, params. Now, anything in my character is not going to be blocking my ray. It's going to be excluded from the ray. Let's go here and try it. Right. So in the demo, I added something like a shield, right? So in my rig, let's add a part. Yeah. Oh, I got an A there. I wanted a P. P for part. And we have some assembly here. Whoops, Control Z. I don't know what happened. Do an Alt click so I can grab it. Yeah, I'm going to drag this over here in front. Or maybe he's got some cool face shield, right? I know I'm spending too much time making something cool and not doing enough time with the ray. All right, that's cool. It's got some sort of blockage there, but I don't want that to be blocking my ray. Let's go ahead and join that to his head. So it's already in the rig. Hit the plus. We'll add a weld constraint. Part 0. Let's go add that to his head. Part 1. That's going to be my part. And now it'll hang out there. And it is in the character. So when I play this, you should see the beam go right through that brick. It's excluded. And it is. Good. But his head still blocks it. Sweet. That's what we want. But now let's make something so that it's like transparent. Like we can make this wall transparent. Even though it's opaque to us, it might be transparent to the beam. Let's try that. I'll go ahead and turn this game off. And we'll go back to our raycast script. There we go. A convenient way to exclude things from raycasting is using the collection service. So let's scroll up to the top and maybe I'll add it to the top, very top. Local CS game get service, collection service. Down here in the params, I think maybe above the params, let's make a filter table. Right, and a filter table, we'll grab this. We want to keep that in there. Control X to cut. Control V to paste. And then let's put the filter table here. There we go. And then we can add stuff to this filter table. What should we add? Well, let's make an exclude table. From the tagged stuff. Exclude, how about tagged table? That way we don't get confused. So we're going to get our collection service and then we're going to get tagged. Everything that we tag, we have to come up with a name. I think we'll call it like exclude ray or something like that. So anything that's tagged exclude ray, we're going to put it in this filter table. How do we do that? Well, let's just do a for loop. For I and V in pairs. And we want the exclude tagged table stuff. We want to go through that. And then we're going to do a table insert to the filter table with V. And that's going to be the object from the exclude tag table. This is going to be like 1, 2, 3, 4. And this is going to be the things that we tagged to exclude. Let's do that now. Let's go over here to our world. And then I'm going to right click. I'm going to get my tag editor. Right. And then this might be a little bit different here. I was messing around with it earlier. Just hit new tag. And then we're going to add exclude ray. That's going to be the tag we're going to use. We want to find this wall and then check. There we go. So that wall has the exclude tag on it, right? If I go here to base plate, ooh, it does not. Wall, yes, it does. Cool. Now, back here, one last thing. If you add things to this filter table, you need to reassign the filter table to the filter descendants instances because if you're familiar with passed by value and passed by reference, you would think that if you updated this table, this value would get those updates automatically. They don't. You have to reassign it to that object. All right. So if you did Java or something, that might get you. Let's go ahead and try it. Let's hit play, and our beam should go right through that tagged wall. And it does, but it still doesn't go through my head. Cool. One more thing that you're going to need for your raycasting basics, right? You may need to be able to exclude things like accessories on the fly, because if you have a pistol with raycasting and you do a headshot, the hat's going to block it. So we're going to have to get around that. But that's hard to put into an exclude list, right? We're going to have to exclude it almost instantly. As soon as it hits an accessory, it says, oh, that's an accessory, exclude it, recast. Let me turn this off. And we'll go back to our cast ray, and let's go ahead and take care of that accessory problem. Let's scroll down to cast ray, and let's say we're making a gun and we want to get a headshot, but the hat or accessory might be blocking the headshot. So we get a result, we get a target, we got to make sure it's not an accessory. If it is, we want to go through the accessory to see what it is. So the target itself will be a base part. It could be a handle, it could be a mesh part. Let's go ahead and get the target's parent and see if that is an accessory. So target.parent is a accessory, because the accessory itself is not going to get hit by the beam. If it is, then let's get our table.insert filter table and stick that target right on in the filter table. If we update the filter table, we have to update our params filter descendants instances with the new filter table. And then let's go ahead and recast the ray. And that's going to happen instantly. So it's going to boom, hit it. Oh, it's an accessory. Cast it again. Next time it's going to go right through because it's in the filter table. This is going to work really good if it's a weapon, because players come in and out of the game, the weapons respawn or reinstantiated, the filter table is not going to fill up. If this is sitting on a server for days on end, this table might fill up and you might need a way to empty it from all the accessories. All right, but we're not going to get into that. Let's go to our workplace. We'll hit play. We'll try this out. I'm going to have the view output window. Now, I should be able to walk in front of this beam. We may get handle once, but then it's going to be head from there on out. And we got head, so it made it through the accessory before it actually tagged the accessory. But now we're getting head from here on, right? And if I go back and forth, we're not going to get handle anymore. It is in the filter table. That's pretty cool. Now, the one thing about these rays, right? It's a straight line out, and people can see, AIs can see, and NPCs can see on a cone, right? You can see around, not just a straight line. So let's do some sweeping action so we can scan an area. Let me turn my game off. And we'll go back to our cast ray. I'm going to close this window so we have some more space. Let's go on down to our while loop. I want to keep the direction of the head the same, but I want to sweep based on this as like a central. This is going to be my central vector. I want to do a for loop, so I'm going to do for I, and I will equal maybe negative 45 degrees to 45 degrees in steps of 5. I want to calculate out the angle, the X and the Y, based on a 5-degree increment. I know that that's kind of tricky. So let's get radians because degrees are tough to work with. So I'll say math.rad I. That's going to give me the radian value instead of the degree value. I want to get an X value. I'm going to use the dir X, multiply it by math.cosine RDS minus dir, and we're going to go back and forth, so I'm just going to do X and Z. So dir dot Z times math dot sine rads, right? And then I'm going to do a Z. I need to get a Z value, dirx times, oh, I keep doing that space. I want it to all fit on one line. That's why I'm not doing the space. Sine RDS, and this is going to be plus dir dot Z math cosine RDS. How did I get that? I had to look that up. All right, so then let's grab this. Not the weight though. Let's keep the weight there. I'll do a Control X to cut it. Control V to paste it. I'm going to need a new direction here and our visual helper too. So let's go ahead and make local. I'm going to call this dir 2D. Vector 3 new, and then I'm going to get the X value I calculated. I'm going to use the original diry and then the Z. Now I'll just get this, Control C, Control V, Control V, and then our ray and our visual helper will follow along. Now we need to speed things up a bit. I'm going to get rid of some of the weight. I'm actually going to put a little pause here so we can see something happening. I'm going to get rid of this 0.2 here. And now that the beam's moving, we don't need to retract this anymore. So I'm going to delete these two lines of code on 15 under Create Visual Helper. And let's go ahead and see what we got for our scan. Here we go. Let's try this out. All right, looking good. All right, let's go to our view output. And we tagged that wall as not to be viewed, so we're not getting any registers for there. Looking good. All right, let's make it more three-dimensional so we can scan a cone. I'm going to hit the stop button. Let's go back to our raycast, and we're going to modify our code so that we can make a cone. We can scan more stuff. Now, if you're thinking this is pretty resource intensive, it is. I might just do like 10 points at random within the cone, right? But I want to show you a complete scan or semi-complete scan, right? Because we're doing 5-degree increments. Let's do another for loop. So 4, and let's say J. Let's go negative 15 degrees to 15 degrees in steps of 5. And I'll put my end down here. I'm going to reformat my document so it looks good. All right, so right here, we're going to need one for the Y component to convert to radians. So I'll just call that rads Y, and this is going to be the J. And then I'm going to need a Y component in here. Let's see, which one's the closest one? I'm going to use, they're both good. Let's do a Control C, Control V. I'll make this one Y, right? I got to change some stuff. So this direction is going to be dir Y. This is going to be, the cosine is good. We'll do rads Y. And then we can keep this one Z, but I'm going to do a rads Y here. Let me just check this. Yep. Looking good. Let's get our Y in here now. Y. Let's make this dir 3D. Control C, Control V, Control V. And let's give it a try. Let's go ahead and hit the play button. And we should be able to scan a three-dimensional cone. It's a square cone, but that's pretty cool. That's pretty cool. It is using up a lot of resources though, right? You gotta realize that. But Yeah, we're getting a lot of body parts too when we stand in there. All right, so hopefully that gives you enough information on raycasting to get up and running. I will see you in the next video.